Today we're going to be looking at finding common factors and common multiples. We're going to start with finding common factors. You can use what you already know about factors to help you find common factors. A factor is a number that is multiplied by another number. And this is what we have already learned in 4th grade. 3 times 2. The digit 3 and the digit 2 are both factors. 4 times 5, the digit 4 and 5 are factors. And we know that the product of 2 times 3 is 6, and the product of 4 times 5 is 20. The factors of 6 are 2 and 3. And when I'm listing factors, I would list them in numerical order. The factors of 20 are 4 and 5. Now let's apply this to what we're going to be working on today. A baker is arranging cookies on a rectangular cooking sheet. He has batter for 8 oatmeal cookies and 12 chocolate chip cookies. He wants to arrange all of the cookies in equal rows, and he wants each row to have the same type of cookie. How many cookies can the batter put in each row? I'm looking at this word problem and I can see it's about a baker who is going to be baking some oatmeal cookies and some chocolate chip cookies, but he wants to arrange them in a specific way. I can use common factors to be able to help me solve for this question. How many cookies can the baker put in each row? When I'm looking at finding common factors, I'm going to look at the factors for the oatmeal cookies. And then I'm going to look at the 12 chocolate chip cookies. And I need to find factors for 8 and 12. So I'm going to start with the 8 oatmeal cookies. And when I'm looking for factors, I'm simply going to find all the numbers that multiply to get 8. 1 times 8 gives me 8. And 2 times 4 gives me 8. And I'm going to look at 3. There's not anything times 3. And I go to 4 again, 4 times 2. But I already have the factors 4 and 2 listed here, so I don't need to list them again. Now I'm going to go find all the factors of 12, starting with 1. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 5 times, nope, 5 doesn't work. 6 times 2 works. I already have the factors of 6 and 2 listed here, so I don't need to repeat them again. The next thing that I need to do is take the factors that I have for 8 and the factors that I have for 12, and I need to list them in numerical order. So when I look at the factors for 8, I am going to start with 1 to list them in order. So I see 1, and then I see 2. The next would be 4, and then 8. So I have listed those factors in numerical order, and I'm going to do the same for 12. 1, 2, 3, 4, 6, whoops, 6 is here, and then 12. Okay, now I have my factors listed. The next thing I need to do is see what they have in common, because we are looking for common factors. What factors are the same for 8 and 12? I see there's a 1 in both 8 and 12. The 2 is a factor of both 8 and 12. And 4 is a factor for both 8 and 12. I will double check. I see that I have an 8 here, 3, 6, and 12 left. So I have found the factors of 8 and 12. I go back to my question, how many cookies can the baker put in each row? He can put 1, 2, or 4 cookies in each row. And we can demonstrate that on the cooking sheet. So I can take the 8 or I can take the 12 and I can demonstrate that. And I have demonstrated that for you here on the baking sheet with the 8 oatmeal cookies. One row That represents our one row that he can do it. He can also have 2 rows of oatmeal cookies, 1, 2 rows, 1, 2 rows, or he can have 4 rows, 1, 2, 3, 4. And you can see that there are the same number, because remember he wanted the same type of cookie in each row. So these are all oatmeal cookies, so he would have the same type in each row, and we could do the same thing with demonstrating the chocolate chip cookies. Now let's work on finding common multiples. When we are looking to find common multiples, the easiest way to explain it is that we are going to be looking at skip counting. So this is something that you've already done as well. You know how to skip count. Let's read this. An ice cream truck visits Zamaya Street every 3 days and Ashland Street every 5 days. May 31st was the last day the truck visited both streets on the same day. What are the next 2 days the truck will again visit both streets on the same day? So I can see that this is about an ice cream truck visiting Zamaya's and Ashland Street, and we need to figure out when those 2 students will have the ice cream truck visit their street on the same day. Now there's some information that we need to make sure we take care of in this problem. We can clearly see that we're going to be talking about months. So May 31st is a month, and it's the last day of the month of May. So I know that I'm going to be going into June when I'm talking about this piece, when I'm trying to figure out whether the next 2 days the truck will visit both streets on the same day. I know that for Zamaya Street, every 3 days, and Ashland Street is every 5 days. So I'm going to look at finding common multiples. And I'm going to start with finding the common multiple of 3. And I'm going to go ahead and note that I'm talking about the month of June. So we're talking about every 3 days. So we would simply skip count by 3. So I'm going to include 3 as I'm doing my multiples of 3. So I'm going to have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So that's what I'm looking at when I'm skip counting by 3. And I'm going to do the same thing, and I'm going to skip count by 5s. 5, 10, 15, 20, 25, and 30. Notice that I'm stopping at 30 for both of these because I know in the month of June that there are 30 days. So I don't need to keep going because that would exceed the amount of days that's in June. The next thing that I'm going to do is look for common multiples. What do these have in common? So I'm going to scan the 3's, multiples of 3. I'm going to scan the multiples of 5, and I can see that 30 is what they have in common. So to answer this question, what are the next 2 days the truck will again visit both streets on the same day? Well, I know that it will visit on June 30th will be one of the days. My question asks, what are the next 2 days the truck will visit both streets on the same day? So if I wanted to find another day that they would visit, I would do the same thing. I would start with June 30th thinking that I need to go to my next month, which will be July, and I would skip count again for July, and then I can see what the next days would be. So on June 30th, Zamaya Street and Ashland Street will have the pleasure of receiving ice cream from the ice cream truck. Let's practice a little bit more with common factors and common multiples. When I'm looking at common factors, I need to recognize that there is a key word here in common factors, and that is the word fact. Whoops, let me get that word. So that is the word fact. And I'm looking for being able to prove or disprove if a digit is a factor or not. For example, 4. I need to find the factors of 4, all the numbers that are multiplying. So I can see that 1 times 4 is 4. Is that a fact? 1 times 4, is that equal 4? Yes, because I can prove it. I can draw a picture to prove it. I can do an array to prove it. So I know that this is a fact. And let me think about 2. 2 is 2 times something 4? Yes, 2 times 2 is 4. That is a fact, and I can prove it. So when I'm looking for factors, I'm trying to find what are the factors or what are the facts of 4. And I need to do the same thing with 6. 6 equals what factors? Starting with 1. 1 times 6 gives me 6. 2 times 3. And 3 times 2, I already have that. 4 times something, no. So I am saying that 1 times 6, that's a fact that that's going to equal 6. 2 times 3, that's a fact that equals 6. So when I'm looking at my factors, I am writing 4 equals 1 times 4, 2 times 2. 6 equals 1 times 6, 2 times 3. Because they do, they are equivalent. Those are the factors of these two products. And I simply need to list them in order when I am showing both of those factors. So I'm going to start with 1, and then 2. And I only need to write the 2 one time, and then 4. I don't need to write the 2 twice. I'm going to do the same thing for the 6. 1, 2, 3, and 6. And notice that I cross them off because I want to make sure that I don't leave any out. And now when I find common, I go in and I circle the ones that are the same. I circle everything that I see the same. 1 and 2 is what I see they have in common, so the common factors would be 1 and 2. So I'm looking for the facts that prove what numbers multiply for these products. Now, 16 and 24. It's your turn. You try. Go ahead and pause the video. You should have something that looks like this. Hopefully a little neater than my work though. Did you get them all? Did you get all the factors for 16 and 24? To come up with the common factors of 1, 2, 4, and 8? That 24 was a little bit tricky. You got to know your multiplication facts. Those multiplication facts come in handy when we're trying to find common factors. So you need to keep practicing those if you miss some of the factors for 24. Let's look at finding common multiples. When we're finding common multiples, remember that we are going to simply skip count. So when we find the common multiples of 6, we're going to skip count by 6. When we find the common multiples of 9, we're going to skip count by 9. Notice that I've asked you to list the first 6 multiples. So we start with 6. We always start with that. So we're going to have 6 and then 12. 18, 24, 30, 36. Now I need to list 6 multiples of 9. I'm going to start with 9, 18, 27, 36, 45, and 54. When I'm looking at skip counting or finding multiples, what I need to make sure that I remember is that I'm going to be looking at the MPS. So I am going to make a pattern by skip counting. That's what I'm doing. Once you remember that MPS, make a pattern, skip count, that'll kind of help you not get confused with finding facts for common factors. So those are our distinguishing factors. We also use equal sign when we're showing facts, as these products show what the factors that multiply equal to get the product. And over here I'm just using colons because I am just showing that I am actually skip counting. And skip counting is also related to multiplication, of course. Your turn. You try the next one.